to Easy Elim Learning Simplified. My name is Ruth, and today we are going to discussing on allotropes on carbon and its compounds, and you're going to be focusing on the properties of carbon. So previously we discussed on the allotropes of carbon, so you can go back and check that out. So we'll look at the chemical properties of carbon and then tackle a few questions. So you notice that in the previous lesson, we talked a bit about the amorphous and the allotropes of carbon. So we're just continuing with the carbon and looking at some of the other properties of carbon. So one thing you'll notice is that carbon usually occur widely as a black solid, and it is insoluble in water but soluble in carbon disulfide or organic solvents. The reason why is because, first of all, it's molecular. It is actually non-polar. It does not have polarity. That is the reason why it can dissolve on non-polar substances like organic solvents and cannot dissolve on polar substances like water. So when you look at some of the chemical properties of carbon is that they usually burn in oxygen, as you can see in the diagram. It burns in oxygen to produce a colorless gas that dissolves in calcium hydroxide to give a white precipitate, like you can see in the setup. So when carbon is heated, it glows red and a colorless gas is produced which reacts with calcium hydroxide to form a white precipitate. This gas is confirmed to be carbon dioxide, as later we will discuss. The red glow shows that the reaction produces a lot of heat, and the white precipitate shows that carbon dioxide is being produced. So when you look at the equations, we are going to look at two equations, the burning of carbon in air. So carbon, which is solid, reacts with oxygen in air to produce carbon dioxide gas. So when you look at this equation, it's already balanced. And then when you look at the white precipitate, the carbon dioxide gas produced reacts with calcium hydroxide, which is the lime water, to produce calcium carbonate, which is the white precipitate, plus water. So those are the two equations. So you can see like everything is balanced. We have 4 oxygens in both sides, we have 1 carbon in both sides, and we have 2 hydrogens in both sides. So also carbon behaves like a reducing agent where it reduces elements that are below it in the reactivity series. So for example, if you react a mixture of copper 2 oxide with carbon, it's going to turn it into a brown powder. So you know copper 2 oxide is black in color. So if you heat this, you are going to notice some brown specks in the boiling tube. And then a colorless gas is produced because the carbon reacts with oxygen to form carbon dioxide, which forms a white precipitate with calcium hydroxide. So when you look at the equations, so we start with copper 2 oxide, which reacts with carbon. So carbon reacts with the oxygen in copper 2 oxide to form carbon dioxide, and then copper metal is formed. So when you look at the equation, we need to balance it. So we are going to put a 2 here, and this is going to affect the carbons and oxygen. So what we do, instead of putting the 2 here, we first change the oxygen because we have 2 oxygen on the product. So we can put a 2 here to get to oxide. So in the product, the number of copper atoms have changed. So we have to put a 2 here, which balances the equation. So also carbon has the ability to remove oxygen from some metals, as we said. And this causes the carbon to be oxidized to carbon dioxide, and the metal is reduced to the metal oxide is reduced to metal. So in terms of competition for combined oxygen, carbon can be placed in between aluminium and zinc. So it's going to reduce all the oxides of metals below it. So that's why we refer to carbon as a reducing agent. So if you look at the metals below carbon, we have zinc, iron, tin, lead, copper, silver, gold, and platinum. So we have just discussed the reaction of copper with hydrogen. So let's see how these others behave. So with lead oxide, when you react it with copper, when you write the equation, it's going to be lead oxide plus carbon to form lead solid plus carbon 4 oxide. Remember, lead solid is yellow when hot and orange, yellow when cold, sorry, and orange when hot. This brings a lot of confusion, especially when we compare it with zinc. You'll come to see how zinc behaves. So when we balance the equation, so you can see we have two oxidants this side, so we have to put a 2 here, which affects the lead. Then zinc oxide is going to be zinc oxide, which reacts with carbon again to form zinc metal and carbon 4 oxide gas. So remember, lead is the one that is yellow when cold and orange when hot, and the lead solid is gray in color. So zinc oxide is white when cold and yellow when hot. And when it is reduced, it also forms a gray solid. Iron 3 oxide is brown. So when we talk about iron 3 oxide, so let's do that. Reacts with carbon to form iron, solid, and carbon 4 oxide gas. So the iron 3 oxide, let's not forget to balance. The iron 3 oxide is brown in color. When it's reduced, it changes to also a gray color. So let's balance this equation. Since we have 3 oxygens this side and 2 oxygens, we are going to make them even. We multiply by 3 here and multiply by 2 here. So now we have 6 oxygens this side and 6 oxygens this side, but we have 4 ions, so we have to put 4 and 3 carbons. And that balances the equation. So at temperatures that are about 1200, carbon reduces steam to hydrogen gas. So carbon is in turn is oxidized to carbon 2 oxide. So this forms a mixture of two gases, they're usually called water gas. So if you look at the reaction of carbon with steam, carbon takes away the oxygen from steam to form carbon 2 oxide, and hydrogen gas is produced. So this mixture is what is referred to as water gas. Carbon also reduces hot concentrated nitric acid to brown nitrogen 4 oxide and water, and carbon in turn is oxidized to carbon 4 oxide. It also reduces concentrated sulfuric acid to sulfur 4 oxide and water, while itself is oxidized carbon 4 oxide. So both carbon 4 oxide and sulfur 4 oxide react with calcium hydroxide. They are going to form calcium sulfite and calcium carbonate respectively. So as for the equations, so you start with the reaction of carbon with nitric acid. So it's going to form nitrogen 4 oxide plus carbon 4 oxide plus water. So we have two hydrogens this side, so we have one hydrogen this side, and then oxygens, we have 5 this side and 3 this side. So we need to do a bit of some balancing. So it's going to be, so you notice we have, as I said, like we have one hydrogen and two hydrogens this side. So we are going to put 4 here. So if we place 4 on the nitric acid, it affects the number of hydrogens. So we have to put a 2 on the water. So we have 4 hydrogens both sides. But you can see the nitrogens, these sides are 4, so this side is 1, so we have to put a 4 here. And then the moment we put that 4 there, it balances the equation. All right, so the next equation is for concentrated sulfuric acid. So H2SO4 reacts with carbon to form sulfur 4 oxide plus carbon 4 oxide plus water. So we also need to balance this equation as well. So you notice like also we have 2 hydrogens this side, 2 hydrogens this side, but the oxygens are not equal. You can see we have 4 oxygens this side and 5 oxygens this side. So we can balance the oxygens by putting a 2 in front of water so that we can have 6 6 hydrogen oxygens. So we have 4 and we have 2 plus 2 plus 2 now we have 6 oxygens, and then we can put a 2 here as well. So if we do that, the hydrogens are balanced, but now our sulfur is not okay, so we have to put a 2 here. So initially we had 6 oxygens, but now there are 8 because there is 2 4 plus 2 6 plus 2 8, which balances out with 8 this side. So this equation and this equation is balanced. So let's look at a few questions. Study the diagram below and use it to answer the questions that follow. So you have that diagram. So you can see a mixture of copper 2 oxide and carbon was heated, and there's gas P. Set the observation made in the tube. So we are going to say that the black copper 2 oxide changes into brown color, which is copper, brown copper. Then write the equation for the reaction. So it is copper oxide plus carbon solid to form carbon 4 oxide plus copper solid. Remember we balanced this before, so you're going to put a 2 here and a 2 here. State and explain the observation made when a piece of charcoal is dropped in a jar containing concentrated sulfuric acid, nitric acid. So you're going to see a brown gas because carbon reduces nitric acid to nitrogen 4 oxide, and itself is oxidized to carbon 4 oxide. So it reduces nitric acid to nitrogen 4 oxide and water. Let's not forget the water, and itself is oxidized to carbon 4 oxide. The setup below was used to investigate a chemical property of carbon. So you have a carbon mixture of carbon and copper 2 oxide. The observation made, so it's more or less like the one that we have discussed this question. So the observation is the black copper oxide will turn to brown, and this is on the heating mixture, so we are not going to talk about the lime water. What is the industrial application of carbon in terms of property investigated? So it is used in extraction of metals. We are going to look at the uses, other uses, but you notice most of the uses are just extraction of metal. So that brings us to the end. So next we are going to be looking at other properties of carbon and also the oxides of carbon. So see you then.